Alright guys, Coach Gu. What's up guys and gals? Coach Gu back here once again with another flipped classroom. Wait a second. What's up guys and gals? Coach Gu back here once again with a fun-filled, action-packed, flipped geometry classroom video. So today we're going to be learning about the next way to show that two triangles are congruent. It is the angle side. All right, so so far we have side, angle side, or SAS, and now we're going to be learning the angle side. Now remember, the point of any of these, is to show that two triangles are actually congruent. So, you're looking for, are there three sides that are congruent? Is there a side angle side that's congruent to a side angle side from another triangle? If so, then the two triangles are congruent. We're trying to prove that two triangles are actually congruent. All right, so right here, if two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the triangles are, it says included, it should say congruent. Congruent. All right, and pretty much all that's saying is that you're going from, you have an angle, and then a side that's not between the two angles. If those are congruent, then the two triangles are congruent. So look at our example here. We've got triangle ABC and we have triangle DEF. So in this case, if we're looking for an angle side, look, A is congruent to D. Angle A is congruent to angle D. Look at our next angle, the two congruency marks. Angle B is congruent to angle E. So now we have an angle, and we need a side. So look at our side. We've got right here, BC is congruent to EF. So BC is congruent to EF. So that means we have a side, we have an angle, and a side. And that means our two triangles are congruent. So that means triangle ABC is congruent to triangle DEF. Boom. All right, so let's go straight into some examples. Here we go. Let's go to the first example. Sample AAS proofs. Here we go. So let's look at the given. We always start with the given and we label what we can see. So YZ, that's right here, bisects angle WYX. If it bisects, what does that say about the angle WYZ and angle XYZ? That's saying that angle WYZ and angle XYZ are congruent. They're congruent. So we can go ahead and write angle WYZ is congruent to angle XYZ because that's what bisects means, right? Bisect is to cut in half perfectly with no mistake. 50-50. Okay, anyways. All right, and then it tells us that angle YWZ, that's right here, is congruent to angle YXZ, that's right here. So look, we have two angles already given to us. What can we write in our first line of this proof? We're going to write YZ bisects angle WYX. That is in, where do we get that from? We got that from the given. That's our favorite. It's given. Now, what does bisects mean, right? Why would they tell us that something is bisecting? That's because, as I wrote right here, it shows us that these two angles are congruent because they have been bisected. So, angle WYZ is congruent to angle XYZ, and that is the definition of bisect. The only reason they tell you something like that is bisecting is because they want you to know that two parts are exactly equal or congruent. And what are we going to write in the next line? Do we have another given? Yes, we do. We have angle angle YWZ is congruent to angle YXZ, and that is in the given. All right, so we've taken care of everything that we've been given. So we have an angle, and we want a side. Which side do these triangles share? They share side YZ. But remember, we need to write something that shows that YZ is in fact congruent to itself because both triangles are using that same side. So we're going to go ahead and write YZ is congruent to YZ. And what's that property called? It is the reflexive property. And now we've shown that we have an angle, and a side that are congruent in these two triangles, which means that our proof right here, triangle WYZ is congruent to triangle XYZ is true because why? Angle, side. There we go. All right, let's go to the next example. Ooh, look at this one. They already gave us the whole left column. Oh, baby. So given ABC is congruent to angle CED. So ABC, let's mark that. ABC is congruent to angle CED. Okay, cool. And AB right here is parallel. So I'm going to go ahead and write parallel. The parallel mark is parallel to CE. And C is the midpoint of AD. Why would they tell me that C is the midpoint of AD? That's telling us that side AC is congruent to CD. Remember, that's what midpoint means. It's the same thing as bisect pretty much. So let's go ahead and get into our proof. So step one, angle ABC is congruent to angle CED. That's in the given. Number two, AB is parallel to CE. That is in the given. Good. All right, next one. 3. C is the midpoint of AD. That's also in the oh my, they gave us 3. Wow. Oh, this is easy shopping right here. Number 4. AC is congruent to DC. Look, we already labeled that, and why do we label that? Because that was what midpoint tells us. That's the definition of midpoint. Remember, they're going to tell us bisect or midpoint because they want us to know that one half is congruent to the other half. All right? And number 5, angle BAC is congruent to angle EC or ECD. That's right. BAC is, look, so they drew it like this. BAC, that's right here, is congruent to angle C or ECD. Now, how do we know that? Well, if you see that AB and CE are parallel, then you see this, AD is like a transversal going through these two parallel lines. Like if I extend this, oh, wow. Now we have an intersection. BAC, which is, I'm going to use a darker color so you can see. I'm going to use the orange, okay? BAC is right here. And ECD is right here. What relationship do these two angles have? They are corresponding angles. And corresponding angles, do you remember the special rule about corresponding angles? I'm going to go ahead and write that here. Corresponding angles. If the two lines are parallel and the transversal is going through them, then corresponding angles are congruent. So that is what we can use, the corresponding angles. All right. And last, number 6, triangle ABC is congruent to triangle CED. That's what we're trying to prove. How do we know that? Because look, we've got an angle right here, another angle right here, and our side, which is AC and CD. We have an angle, side. So once again, angle, side. Boom, we have proved it. On to the last question, number 6. First thing we want to look at is the given. And look, they've already labeled it all for us. Oh my goodness, how nice. Look, PR bisects angle QRS. That means they've already labeled it for us, that angle QRP is congruent to angle SRP, angle QR. I'm going to write it up here for funsies. Congruent to angle SRP. All right, next they wrote that in the given, angle PSR right here is congruent to angle PQR. And that's all we're given. But then look, our third side right here, these two triangles share this side. So pretty much you're going to know that this is congruent. And we can go straight into the proof table. Let's go. PR bisects angle QRS. Where do you see that? It's given. Step 2, angle PSR is congruent to angle PQR. Where's that? It's also in the given. Number 3, PRS is congruent to angle PRQ. Where is that? That's the definition. That's the definition of bisect. Remember, why did they tell me that PR bisects QRS? They want me to know that these two angles are going to be congruent. And now, the last one, we're trying to prove that this side is in fact equal to itself. What's that property called? It is the reflexive property. And then look right here. We've got an angle, and a side, and that means we've proved that these two triangle PSR is congruent to triangle PQR with the AAS angle side, and that concludes the last, third and final example problem. So that's the end of this video, guys. So I'll see ya in the next one. Peace.